All right, let's take a look at this question. Solve for all solutions of sine of 2x plus pi sevenths equals negative 0.135 in the interval 0 to 2 pi. Calculator allowed. So the first thing I'm going to do is just let theta equal this 2x plus pi sevenths. So we have sine theta equals negative 0.135. That would give us two locations where sine is negative. That's in quadrant 3 and quadrant 4. Now quadrant 3, if we do pi plus reference angle, we can find this angle. In quadrant 4, if we do 2 pi minus reference angle, we can get an expression for the fourth quadrant answer. Now, reference angle, I'm sure we can solve for theta with arc sine of both sides. But that's not the reference angle. The reference angle is always the arc function of the positive number. That's really what we want to work with. So our answers will be pi plus reference angle, arc sine of positive 0.135 plus 2k pi. That will be all of these answers forever and ever and ever. And we also have the 2 pi minus reference angle, also plus 2k pi. And that'll get us all of these answers forever and ever and ever. Great. But that's for theta, and we actually have 2x plus pi sevenths instead of theta. Okay, so we have 2x plus pi sevenths equals pi plus arc sine of 0.135 plus 2 pi k. And if we solve that, that will be subtract pi sevenths. 2x equals pi minus pi sevenths plus arc sine of 0.135 plus 2 pi k, or 2k pi, your choice. I don't know why you keep going backwards and forwards. And so dividing by 2, I get pi halves minus pi sevenths divided by 2. Pi sevenths times 1 half is pi 14ths. Then plus arc sine of 0.135 divided by 2, and plus k pi. All right, that's one of them. Now the other, in a similar fashion, we would end up with, so instead of pi plus, it's 2 pi minus. So let's subtract the pi sevenths. And it's minus arc sine, 0.135, plus 2k pi. And so x equals, divided by 2, pi minus pi 14ths, minus arc sine of 0.135 divided by 2 plus k pi. So let me highlight or circle these. These are all of the solutions, all of them. Now we're not looking for all of them, we're looking for only the answers between 0 and 2 pi. So now if I let k equal, I don't know, 0, 1, 2, maybe negative 1, get an idea of what these solutions look like so we know which answers are the following, or the final answers that we're looking for. Okay, so so if k equals, I'm going to use negative 1, 0, 1, 2, let's start with those, and if we need to generate more, we will. Now keep in mind, 0 to 2 pi is 0, and if we look at 2 pi, (6.283) ish. Did I round up? Yeah, I rounded down, so this will be fine. These are the values we're looking for, between 0 and 6.28-ish. Okay, so with our calculator, I want to type this in a way that we can change it easily. So how I'm going to do is I'm going to do pi halves. Oh, let me check my mode. Radian. Okay, perfect. This is all radian stuff. Minus pi 14ths divided by 14 plus arc sine of 0.135 divided by 2, and then plus pi times -1. Enter. This one would give me my first answer, -1.73-ish. I don't want that. It doesn't lie within the range. That's okay. I'm going to generate this version of the answers, this quadrant 3 type of answer over and over and over. So now the way I've done this, a lot of you do the up arrow, but some of you can do second entry. I'm just going to now change that -1 to a 0. 1.414. Change that 0 to a 1. Now I'm just letting k equal bigger and bigger values, 0, 1, 2, 3, etc. 4.556. And if k equals 2, 7.697, that's too big. Okay, now for the second one. Let's see what it would take to adjust this. So we don't have pi halves, we have pi minus pi 14ths minus arc sine divided by 2 plus k pi. So let's change this back to -1 and look at that one. Also negative, not the one we want. Let's let k equal 0. 2.849. I don't know what they wanted us rounding this to. It says using a calculator is allowed, although we could write our answers in exact form. Let's let k equal 1. 5.991. That's still good, 0 to 6.28. And this one will probably be too big if I let k equal 2. Yeah, 9.13. So these are the values that give us the final answers that we're looking for. I want to show you that these work. I'm still in radian mode. If I did sine of 2 times, let me do the 4.556. Now note, 4.556 is an approximation. It's not the exact answer. So this won't be perfect, but it should be close enough. So 2x plus pi sevenths plus pi sevenths. This should be -1.35 right around. There we go. We can see this value works. You can check all of these and they'll all be right around -0.135. Okay, I hope this helps. In general, you can find all the solutions and then let k be certain values to get the exact ones that you're looking for. You could write for k equals 0, 1, and have these two circled answers be what you write on the test, and then there's no rounding at all. Those are the 4 answers. You can approximate them if requested. They just didn't give us how far the decimals should be approximated to. That's why I would still be tempted to go with these exact answers. Just be specific about which k values give you the right range. All right, I hope this helps. Thank you so much.